In lesson 2.2, we learned this method called the substitution method. It's a way to solve a system of two lines, find where two lines intersect each other if one of the lines is in the y equals form. So in today's lesson, the elimination method, let's take a look at this system. How can we solve a system of two lines if both of your lines are in standard form? Well, elimination method works perfect for this. And let's just go ahead and look at, just like the last lesson, we're going to do questions right off of your homework assignment to keep this straightforward and simple. So the elimination method is, oh, there's a typo there. Let me fix that. That should be a Y. The elimination method works great if both lines are in standard form. And then you also need one of your columns of variables must be opposites, meaning like 5x and negative 5x as an example. If both of your equations, both of your lines are in standard form and one of your columns is opposites, like 5x and negative 5x, what you're going to do is you're going to turn these two lines into kind of a gigantic longhand addition problem. And I'm going to kind of work from right to the left here, meaning we're going to add up our columns. We're going to take negative 23 plus 8, which is negative 15. We're going to take negative 4y plus 9y, which comes out to a positive 5y. And then we're going to add 5x plus negative 5x. And guess what? You could write that comes out to 0x, or as we've learned in this class, when you get a coefficient of 0 with one of your variables, you can actually just say that it vanishes, that it disappears. 0 times anything is nothing. So a lot of times what I'll do is I'll just cross out the 5x and the minus 5x, and I will say, x's, you have been eliminated. That's why this method got its name. And look at how great this is. When you eliminate the x, because these are opposites, it's so easy to solve for y. We're just going to divide both sides by 5. And just like that, we have our first answer. Y is equal to negative 3. So we're going to put that in our second box here. Y is equal to negative 3. So elimination method, a lot of students find it pretty simple to get this first answer. What's a little trickier about the elimination method is now how do we find the other answer, in this case the x value. Well, what we're going to do now is we're going to take either one of these lines. It does not matter which one. I'm just going to write down the first one. Okay, and we have our y answer. We're going to plug negative 3 in for y. And now we're going to use this information. We're going to solve this like an equation to solve for x. Negative 4 times negative 3 is positive 12. So we can solve for x in two steps. We'll subtract the 12 from both sides and then divide by 5. So 5x is equal to negative 25. Divide both sides by 5. X is equal to negative 5. So once again, I'm not making you graph these lines by any stretch. We don't have any graph paper here. However, we know that if we were to graph our first line and our second line, the point where they intersect here, it would be at the point negative 5 comma negative 3. That's the one ordered pair that is a common solution to both of these lines. So this technique is all fine and good and wonderful if you have a column of opposites already and both your lines are in standard form. But what if you don't have opposites? Let's look at question number 4. Here in question number 4, we don't have any opposites. If we were to try to add question 4 together the way it's written right now, let me put a 1 here for the x. If we were to try to add these together as it's written right now, let's see, we would do 5y plus negative 10y is negative 5y. 1x plus negative 7x is negative 6x. If you don't have opposites already with one of your columns, when you try to add the lines together, nothing gets eliminated in this case, and you're not any closer to being able to solve for x or y. It really just kind of complicates things, confuses things. You're left with another line that really doesn't help you at all. So the elimination method only works if we have opposite columns. So what are we supposed to do in a case where we don't have opposite columns? Well, maybe you guessed it. We are going to create opposite columns through multiplication. So we could eliminate either the x or the y here. It is our choice. I'm just going to eliminate the y column because that's what my directions ask me to do. Here I have a 5y. Here I have a negative 10y. I need to find something called the lowest common multiple between 5 and 10. Now the multiples of 5 are 5, 10, 15, 20, 25, 30, etc. The multiples of 10 are 10, 20, 30, 40, etc. And if you look, the lowest multiple that these numbers have in common is 10. What that means now is I need to turn both of these into 10y's. Now the way I can do that, all I'd have to do here is multiply this by 2. I'm going to take this in. Now, we can't just multiply the 5y by 2. The rule is you have to multiply everything in the equation by 2, the left hand and the right hand side of the equation, in order for it to keep its identity. We need to multiply everything in this equation by 2. This first line is going to become a 2x plus 10y equals 54. Now, my second line, I already have a 10y, so I'm going to just keep it the same. You could say, if you wanted to, you could say I'm going to just times it by 1, but nothing's going to change. Negative 7x minus 10y equals negative 89. Well, look what happens. By finding a common multiple and multiplying this top equation by 2, I've now created a column of opposites. And so my elimination method is going to work wonderfully. I can add these together. Here I have a negative 35. Here my y's get eliminated. They cancel each other out. 2x plus negative 7x is negative 5x. Since my y's have been eliminated, I can very simply divide both sides by negative 5. And I have my first answer. X is equal to 7. Oh, now question number 4 is actually a multiple choice. It just said, what first step would allow you to solve this system by eliminating the y column? We would multiply the top equation by 2. And then I've already started question 5 for you. X would be equal to 7. And then I'm going to have you finish this on your own, but just a reminder, to find y, to solve for y, we can just plug our 7 in for x. And when you solve this equation for y, that will tell you what your y value is. I'll let you do that on your own. Now, I do want you to be aware, sometimes you have to multiply both of your lines by a factor, and sometimes you'll have to make one of your lines negative. So for example, here we have a 3x and a 4x, a 2y and a 5y. It does not matter which column we want to eliminate here, the x's or the y's. I think I already know the lowest common multiple of 3 and 4 is 12. So I'm just going to go ahead and eliminate the x's. So I know my lowest common my multiples of 3 are 3, 6, 9, 12. My multiples of 4 are 4, 8, 12, 16. The lowest common multiple, the LCM, is 12. I need to turn both of these into 12x's. So I know my first line, I can just multiply everything by 4. 12x plus 8y equals 68. And then I also know then I can multiply everything in my second line by 3. That would give me a 12. However, remember, I need these to be opposites. So since this is already a positive 12x, I need to make sure I'm turning this into a negative 12x. So in order to make these opposites, in this case, I'm going to multiply everything in the second line by negative 3. This becomes a negative 12x, a negative 15y, and a negative 96. Now I have my opposites, 12x and a negative 12x. When I add these together, those are going to cancel out. 68 plus negative 96 is negative 28. 8y plus negative 15y is negative 7y. divide both sides by -7, x is equal to 4. Okay, and again, I'm going to let you finish the rest on your own. You would have to go through now and solve for y, but this is the setup. In some cases, you have to multiply both of your lines multiple. And the last thing I'd like to go over, I want to go over part of question 10 with you. How do we know if a system has no solutions or infinite solutions if we're using the elimination method? Well, here's the difference. So if you ever go to do elimination on two lines and both your x and your y cancel out, we're going to write that as a 0. You know that something kind of fishy is happening here. You know it's going to be a special case. What you would do in this case is go ahead and cancel out our x's and our y's. We're going to write a 0 there when everything canceled out. And then we're going to take 15 plus -15, which is also 0. When your x's and your y's cancel out, both cancel out, you want to look at your statement that's left. If it's a true statement, you're going to say that this system has infinite solutions. These lines are the same. However, in a case like the second one, if your x's and your y's all cancel out, but 100 plus -50 is +50. If your x's and your y's both cancel out, but you're left with a false statement like this, now we would say these lines are parallel. There is no solution to this system. All right, so that's all I got for you. That's all I have for you. Best of luck on this. Take care.